Your video, it looks off, Rahul.
Ma'am, my camera is on.
Okay, now it's. We get something. Students, last 2 minutes. Okay, students, now everyone, hello, everyone, you can now submit your quiz, otherwise it will not accept your response. Submit it right now. Now I'm closing the response. Anyone is remaining? After that, you are not able to submit it. I'm closing the response. Anyone is remaining? Last call. I'm closing it. Okay. So how was the quiz, student? Is it fine? Was it tough? Was it easy? How was your quiz? Yes, it's good. Sahil, Sakshi,
Yes, ma'am, it was good.
Shubham, Harsh, Jay. Where is Eva?
Good, ma'am.
It was good
Ma'am, it was good.
because Eva got highest mark in this. Okay. My screen is visible, right, student?
Yes, ma'am.
Okay. Student, yesterday we had completed code conversion chapter, and that we discussed that suppose if we are dealing with assembly language, or for example, if we are giving the input through keyboard, always there is a need to convert the code from one system to another number system, right? So the need of code conversion we discuss, and then we discuss around 4 to 5 conversions and how to write a program based upon that. That was the last point. Student, we discuss time delay encounter in lab. We discuss how to generate a counter, how to provide a delay in between to count, and for that delay generation, two technique we had already discussed in our lab. Remaining two technique we want to discuss in our theory session because lab में हमारा जो भी delay generation था that was around in terms of microsecond and millisecond, right? So that purpose can be solved with the first two technique. So now we want to focus on to more technique. Generally क्या होता है, you require your delay in terms of millisecond, in terms of second, right? So at that time always you need to go just a minute, student. Am I audible properly, students? Am I audible to you, students?
Yes, ma'am.
Correct. So, generator delay is very important while designing a counter. So, that generation of delay we discussed by using first two technique in our lab session. Now, today we want to discuss about two more technique. The limitation for first two methods should be clear कि यहाँ पे if you use NOP instruction ना, that NOP instruction will give you a delay in terms of microsecond, right? 2 microsecond maximum if you are taking 1 megahertz to megahertz frequency. So that is a very less delay. So we move to the second method, which is using register pair. Using register technique. While using register technique, you have a register which will load your data, which is FF. Now, if you say, even if you are loading the maximum value inside your register, you are getting your delay that is in terms of millisecond. So what can be done if I need my delay in terms of second? So for that, you can move to the either third or fourth technique, right? Again, I'm repeating microsecond delay. You always can go for the first method. For millisecond delay, you can go for the second method. But in terms of second, if you want your delay, you cannot go with first two method. So you need to choose in between third and fourth method while designing a delay in terms of seconds, right? For example, student, हम लोग जो भी जितने भी applications use कर रहे हैं, whenever we are using a display device, we know the minimum delay that we are getting or that we want that should be in terms of seconds, right? So always we have to check for the second delay, and that we are getting through last two techniques. Just try to understand third technique where we are using a register pair. Now, student, time delay using register pair, just compare it with the previous. In previous, we have a register, so we can load how much data into register? What was the maximum data that we can load it into the register? Am I audible, student?
8-bit.
8-bit data, and the maximum data that you can load it into the register is the FF. Now here, instead of FF, you can load maximum data into your register pair. It can be F, right? We know whenever we want to load register pair, we have to use LXI instruction. जब हम लोग whenever we are loading register, हम लोग जब register को load करते थे, we are using MVI instruction, right? But here we are loading register pair, so LXI instruction will load our register pair BC. Here no constraint, you can take any register pair, BCD, HL pair, any register pair you can take. Now if you remember, हम लोग का जो ये register वाला method था, उसमें we are after loading register, we are decrementing register, and we are checking whether this decrement of value, counter value will become 0, 0 or not. If it is not, then it will go and check for the loop again. Same way, the same procedure we are following here. We are loading a register pair. Instead of DCR, we are using DCX. Why? Because now we don't want to decrement one register, but we want to decrement register pair. DC pair को हम लोग को decrement करना है. That's why we are using DCXB. Now, student, try to understand the importance of these two instructions after DCX. We are transferring the content of C into accumulator. मतलब after decrement, whatever the content of C that we are transferring to accumulator, and we are performing an ORing operation with B. Now, what is the use or why, what is the need or what is the importance of this two instruction? Student, just tell me if my register pairs content 2384, BC pair में मेरा 2384 है. If my DC pair contains the same data that mentioned above 2384, and if I decrement it by 1, What is the content? 2384 is my content, and if I'll perform a DCXB, what will be the content? My question is 2384 से आप डेटा लोड कर रहे हो, उसको डिक्रीमेंट कर रहे हो, then what will be the content of DC pair after decrement? Can you hear me, student?
Yes, ma'am.
So 2384 को रजिस्टर पेयर को आप डिक्रीमेंट कर रहे हो, तो आपका क्या रिजल्ट आएगा आफ्टर DCXB? That is my question. DCXB will decrement your register pairs content by 1, then what will be the result? Yes, please go ahead. और a student 2384 is my content, उसको आप एक डिक्रीमेंट कर रहे हो, then what is your content?
2383.
Correct. Why we are taking so much time? It will be 2383. 2383. Suppose उसको भी मैं एक से डिक्रीमेंट कर रही हूँ, then what is the content?
2382.
2382. So student, you can identify here कि मेरा जो भी C रजिस्टर का कंटेंट है वही डिक्रीमेंट हो रहा है. Can you relate with my discussion? Right? Even if I am decrementing my register pair, तो मेरा जो डिक्रीमेंट हो रहा है वो कहाँ से हो रहा है? विद द लोअर ऑर्डर रजिस्टर, राइट? मेरा सी का कंटेंट ही एक एक रिड्यूस हो रहा है, बी का कंटेंट में कोई चेंज नहीं आ रहा है. आर यू गेटिंग मी स्टूडेंट? 2384, 2383, 2382 एंड सो ऑन. ये बी के कंटेंट में कब चेंज आएगा? whenever it will become FF and then it will become 00 at that time only this content will change. Otherwise जो भी आप डिक्रीमेंट करो, whether you are using DCR or you will use DCX, आपका जो लोअर ऑर्डर रजिस्टर होगा उसमें से ही एक एक डिक्रीमेंट हो रहा है, राइट? सो विद दिस टू इंस्ट्रक्शन व्हाट वी वांट टू मेक श्योर इज कि मैं अपना सी का डेटा ए में लेके उसको ओरिंग ऑपरेशन कर रही हूँ बी से. मतलब whenever I'll come out of the loop, my B and C both the content must be 00. समझ में आ रहा है स्टूडेंट मैं क्या बोल रही हूँ? Suppose if you are saying that my content of B and C is like 2384, we all can understand कि जब भी I'll write DCX, ultimately that will subtract 1 from my lower order register. Yes or no? Are you following my discussion, student? Yes or no? Right? Now ये जब 00 हो जाएगा, when it will become 00, at that time you need to make sure कि आपका B भी 00 होना चाहिए, अदरवाइज आप लूप से बाहर आ जाओगे, राइट? सो व्हाट यू नीड टू मेक श्योर कि मेरा C और B दोनों कंटेंट 00 है, मतलब माय होल रजिस्टर पेयर इज 00, देन आई विल कम आउट ऑफ द लूप. सो टू मेक श्योर about register pairs to be 0, we are writing this two instruction कि हम लोग उसको डिक्रीमेंट कर रहे हैं, बट वो डिक्रीमेंट हो रहा है रजिस्टर सी में से ओनली, राइट? इट विल डिक्रीमेंट फ्रॉम ओनली लोअर ऑर्डर रजिस्टर. सो व्हाट वी आर डूइंग इज सी का डेटा ए में लेके उसको ओरिंग ऑपरेशन बी से कर दिया. उससे क्या हुआ कि अगर ए और बी और सी दोनों में से अगर किसी भी एक का डेटा भी अगर 0 नहीं है, इफ इट इज 1, देन इट विल नॉट कम आउट ऑफ द लूप, इट विल स्टे इनसाइड द लूप. एम आई कम्युनिकेटिंग स्टूडेंट? राइट? सो इट विल कम आउट ऑफ द लूप व्हेन होल रजिस्टर पेयर विल बिकम 00, राइट? प्रीवियस केस में इजी था. देखो यहाँ पे सिंपली क्या था, यू आर राइटिंग वन रजिस्टर and you are checking the condition of that particular register whether it will become 00 or not. But here instead of register you are using register pair, so you need to make sure कि आप ये पूरा register pair है वो 00 हो जाए, right? How you will make sure कि आप DCX कर रहे हो तो C का तो obviously decrement हो रहा है, but whether your B is also 00 or not, that we want to make sure. तो वो हम किससे करते हैं? किसी का डेटा ए में लेके उसको ओरिंग ऑपरेशन बी से करके, इफ एनी ऑफ द इनपुट in between B and A will be 1, you will not come out of the loop. So we are making sure कि हमारा पूरा का पूरा register pair will be 0, then only will come out of the loop. I hope I am communicating, student. Are you getting my discussion, students? Yes, sir. Are you getting, student? Should I repeat any point? Vishal, Mukund?
Clear, ma'am.
Clear? Harsh, Eva, Sakshi?
Yes, ma'am.
Yes,
Right?
ma'am.
Correct. So we need to make sure, student, in case of register pair, that your whole register pair will become 0, 0, then you will come out of the loop. Now simple, otherwise if you map it with the previous technique, which was by using register, the same steps we are following. We are loading a register pair, we are decrementing it, and we are checking the condition whether it will become 0, 0 or not. To more instruction we are making, we are adding over here is to make sure that आपका पूरे का पूरा register pair is 0, 0, right? It may be possible कि काफी टाइम पे you will experience this कि अगर आप ये ओरिंग ऑपरेशन वाला नहीं करोगे, then if your C becomes 0, then it will come out of the loop. All right. So what we need to do is कि we need to take, obviously ORA operation करना पड़ेगा, but OR एक करने के लिए we all can understand for any arithmetic or a logical operation one data must be in accumulator. That's why we are transferring the content of C into accumulator, and then we are performing an ORing operation with B register. I hope I'm communicating, student. Any doubt here in this? Yes or no? Now just tell me, while I'm writing this loop to generate a delay, how to find the total delay? That procedure will be same. कि आपको outer loop का delay find out करना है, आपको loop का delay find out करना है, and that combinedly, if you add this two, will give you a total delay. Okay, now if you this technique is in front of you, just tell me how many instructions are inside the loop. How many instructions? To find the total delay, we need to find outer loop delay and loop delay, right? How many instructions are inside the loop? Yes? Okay, कितने instruction आपने loop में लिख के रखे हैं यहाँ पे? How many instructions you are writing inside the loop? Or how many instructions you are writing outside the loop? लूप के बाहर कौन सा एक इंस्ट्रक्शन है स्टूडेंट यहाँ पे? I don't know whether you are getting my voice or not. So it's very simple question, student. What I'm asking is, which is the instruction that is outside the loop here? कौन सा इंस्ट्रक्शन एक ही बार एग्जीक्यूट हो रहा है?
LXI.
LXI.
Okay, so why we are taking that much time? LXI instruction, this is the first instruction, and that will execute only once, right? The remaining instruction will execute how many times? This count times, right? We know that this count we are loading here is in hexadecimal, but we need to take it into a decimal, right? So अगर मुझे total delay find out करना है, if I want to find a total delay, what I need to do is I need to find a loop delay and outside the loop delay, right? What is my loop delay? What is my outside the loop delay? That I can find from the how many t state it will require to execute, right? For example, my outer loop delay, only one instruction, and which is LXI. So it will take how many t state? It will take how many t state? 10 t state. Are you getting me, student? आपके आउटसाइड लूप में एक ही इंस्ट्रक्शन है, एंड दैट विल टेक 10 t स्टेट. सो 10 into t, that will be the time required to execute my outer loop, right? 10 into t, that will be the time required to execute my outer loop. Now if my t is 0.5 microsecond, then 5 microsecond I'll take to execute my outer loop. Okay, how many t state inside the loop? How many t state inside the loop? It will execute how many t state? Yes, 6 plus 4 plus 4 plus 10. So how many T state? 24 T state. Student, can you hear me? Yes or no?
Yes, ma'am.
Okay. So
Yes, ma'am.
24, yes, 24 T state you can see here, that is inside the loop. 10 plus 4, 14 plus 4, 18 plus 6 is 24, right? So this 24 T state will execute how many times? 2384 hexadecimal. So equivalent decimal we need to first find out. So 2384 equivalent decimal is 9092. मतलब ये 24 T state will execute 9092 times. I hope I'm communicating, student, right? So with this understanding, if you check for the total delay that you will get, so outer loop में as we discuss only T state is there. Loop में आपके 24 T state है and that will execute 9092 times, 9000 times. So ultimately 218208 T state will be executed. Yes or no? Right? Now total delay equal to आपका लूप में कितने टी स्टेट एग्जीक्यूट हो रहा है 218208 outside the loop 10 T state, so we are adding this 2 and we are dividing here. Either you will multiply it with T state or you will divide it with frequency, will give you a equivalent delay, right? So here if you calculate it, you will find your delay in terms of 109 millisecond, right? Simply आपको क्या करना है, आपका लूप में कितना टी स्टेट है 24 मल्टीप्लाई बाय टी इनटू काउंट. व्हाट इज द काउंट? 2384. 2384 is hexadecimal, so 9092 is your count value. That many times this 4 instruction will execute, right? So 24 into t into 9092, that will be your loop delay. Outer loop में एक ही instruction है which will take 10 into t, 10 t state, so 10 into t will be its equivalent time. Now to find total delay, outer loop is 10, inner loop is 24 into 9092 into t. Whatever answer you will get, that much delay you are able to generate by using register pair. And if you calculate it, you will find for 2 megahertz frequency, it is around 109 millisecond, right? You can identify previous case में using register, the maximum delay that we are getting is approximately 1.8 millisecond, while here it is 109 millisecond, right? It is 109 millisecond even if we are not taking maximum value, right? हम लोग ने maximum value नहीं लिया. For example, if I load it with the maximum value, मतलब 2384 की जगह पे अगर मैं FFF लूँ, that is the maximum value that I can take. So that many times I can execute my loop. So for example, if I'll take maximum value, which is FFFF, so I can repeat my loop how many times? 65,000 times. Am I communicating, student? यहाँ पे जो आपका 9,000 times repeat हो रहा है loop, that I can repeat for 65,000 plus times if I load it with the maximum value. I hope I'm communicating, student. If it is repeating 9,000 times, then also I'm getting my delay in terms of 109 millisecond. So just imagine if I repeat it for a 65,000 time, what can be the delay, right? Am I communicating, student? Yes or no? Are you able to understand, student? Yes,
Yes,
Ayush?
ma'am.
Okay. So whenever you are using, student, register pair to load or to generate a delay, now there will be no constraint. You can generate a delay in terms of second, even in terms of minute also you can generate a delay, because you can imagine here कि यहाँ पे मैं जो रजिस्टर पेयर को लोड कर रही हूँ, दैट इज ओनली विथ 2384. अगर आप डेसिमल में कन्वर्ट करोगे 9092 टाइम्स ओनली आई एम रिपीटिंग दिस लूप, and I may have a capacity to repeat it for 65,000 times, right? So you can imagine कि accordingly you will get how much delay, right? So now in terms of delay, there is no constraint. You can generate a delay of each and every category if you want. In terms of millisecond, obviously you will get. In terms of second, you will get. Even if in terms of minute also, you can generate your delay, right? So I hope I'm communicating, student. Just try to understand this. This is already uploaded. The slides are already with you. You just try to understand how we are taking this loop and how we are finding the equivalent trace state that is required to execute, right? The students, now if you will observe this technique, the thing will be same कि आप अपना रजिस्टर पे लोड कर रहे हो, उसको डिक्रीमेंट कर रहे हो और उसको चेक कर रहे हो. Obviously you need to check both the registers, so that's why you are writing these two instructions. Now जब भी आप counter in terms of second you want, before this you are mentioning some count value, and after that you will update your counter, right? So in between your two count you will get the delay of the value that you want in terms of second, also in terms of minute also, right? Okay, any last point to discuss for today? Still one more technique we want to discuss, and that is about nested loop or loop within a loop. After that, we will check for few programs, which is ultimately the practice of generation of delay and counter, right? So, student, आप अपना stack subroutine और code conversion देखोगे ना? So उसमें very few fixed programs only, there will be that programs only or that concepts only. But timer and counter will give you a flexibility. Obviously आपका program short ही होगा, right? The concept is also limited, but if I only change my frequency, then also you will find that your answer will be different, or your count value will be different, or your delay will be different, right? So fundamentally, just try to understand that which technique we should use. First select that technique, and then simply with that technique the T state. ऐसा भी नहीं है कि अगर मुझे T state सारे instruction का पता है तो ही I can deal with this particular chapter. Only 5 to 6 instructions का T state आपको पता है, then also that will be okay, because loop तो fix ही हो गया, then you need to only go with that only, right? So I hope technique number 3 is clear to you. Once we will discuss technique number 4, and then we will go for the example or a practice for each and every technique by considering 3-4 counter design, right? Okay, so today we are keeping up to here. Any last point that you want to discuss, students? By tomorrow you will get the syllabus for your mid-semester exam, and just check Google Classroom.